Chapter 2, we get into chemistry. So all of the material in the universe is referred to as all the matter in the universe. So if you remember, matter is the stuff that makes up the universe, whether it's solid or a liquid or a gas. So the matter is made up of elements, and the elements are combined into compounds. So matter is anything that occupies space and has mass or weight. Space and mass, basically stuff, even if it's invisible, like gas in the atmosphere. And matter is found on Earth in three basic physical states as a solid. And by the way, water, this is water. Water is a really good material, compound, to explore these physical states, because water exists as solid ice. Matter is also found in a liquid state. Think of liquid water, like in the oceans. And then matter can exist as a gas. Think of the clouds in the sky, or the water vapor in the sky, in the atmosphere. That's the gas state of water. Okay, so three basic physical states for matter. So an element is a substance that cannot be broken down by normal chemical means into any other substance. If you think about something you're familiar with, an element like gold, if you cut a piece of gold in half, the two pieces are still gold. If you cut them in half again, it's still gold, the element gold. You can do that theoretically all the way until you get to a single atom. And that single atom will still have the chemical characteristics of gold. So it's the element of gold. The same thing for another element, like let's say silver, right? When you get down to the atom, if you could do that, you can't break it down any further through normal chemical reactions. So all matter is composed of chemical elements. For example, carbon, oxygen, and gold. And most matter is made up of a combination of these elements, and that gets us to substances, or compounds, as they're called. So here's the periodic table of the elements. So notice up here, carbon, oxygen, and gold. The periodic table of the elements are abbreviated. C for carbon. What do we have? Oxygen and gold. O is for oxygen, and gold is abbreviated AU. Okay? Cu, copper. B is boron, N is nitrogen. He is hydrogen. Sorry, helium, because hydrogen is H. Right? Sodium is Na. Potassium, K. Calcium, Ca. Okay? I learned all these during my chemistry courses. You do not have to learn these, except for a few of them, like H for hydrogen, O for oxygen, C for carbon. Shoot, that might be just about it. Na for sodium, Cl for chlorine, and probably that's about it. Really not very many. Okay? But the periodic table of the elements is set up such, and is organized such, that the elements have similar characteristics in these columns. Okay? The atomic number, by the way, corresponds to how many protons are in the central nucleus of the atom, and we'll get to that in a bit. So, continuing. 4 elements make up most of our bodies by weight or mass. Notice we are mostly oxygen, about 65%. Next, carbon, about 18%. Hydrogen, about 10%. And then nitrogen, about 3 1/3%. So just those 4 elements. Now they're not separate, they're mixed into compounds and such. For example, water is H2O, 2 hydrogens and 1 oxygen. But still, just these 4, carbon, hydrogen, nitrogen, and oxygen, make up most of our bodies and most of the bodies of all the other animals. And everything else, the other 4%, is made up of all these other things. Okay? trace element means something that's in a very small amount, less than 0.01%. They're still very important for good health, but they exist in a very small percentage. And the other things exist in a slightly higher percentage, but still we're talking about like 1.5% to 0.1%, right? And you need calcium for what? Strong bones, right? Phosphorus is important. Sodium and chlorine. You combine these two, you get sodium chloride, salt. That's how we get most of this into our bodies. Okay? But from this chart or figure, what I need you to know or remember is the big four: carbon, hydrogen, oxygen, and nitrogen. There you go. And the abbreviations. Capital O for oxygen, capital C for carbon, capital H for hydrogen, capital N for nitrogen. Okay, so moving into how the elements combine to form compounds or substances. So they can combine in distinctive ratios, like water is always 2 hydrogens with 1 oxygen. Sodium chloride, as I mentioned, table salt, is always made up of 1 sodium combining with 1 chloride to make what's called sodium chloride. And that's just 1 molecule or compound of that, just like one. Like think of a grain of sand on the beach. Of course, this is many, many, many small molecules of sodium chloride, like millions and millions of millions. Okay? So elements are elements combine to form compounds. Sometimes we call them substances. And they can contain 2 or more elements in a fixed ratio. And again, fixed ratio for the specific compound or substance. Sodium chloride is always 1 sodium bound linked to 1 chloride. Okay? Table salt. Water is always 2 hydrogens with 1 oxygen. We don't bother to write the 1 here to indicate 1 oxygen. It's just inferred because there's only 1 oxygen there. Okay? 1 sodium, 1 chloride. 2 hydrogens, 1 oxygen in the compound or substance called sodium chloride or table salt, or the compound or substance called water. For us, we can use the terms compound and substances, or even molecules, interchangeably. Okay? So let's look at the building blocks of matter, these things called atoms. I also use the term element. So again, we can kind of get away with using element or atom interchangeably. An element is a specific atom in a way, like sodium is an element. Okay? But if we look at the structure of these elements or atoms, they do have a unique structural arrangement. So each element consists of 1 kind of distinctive atom. An atom then is the smallest structural unit of matter that still has all the chemical properties of that particular element. So I mentioned, if you had a chunk of gold, right? We all wish that. If you cut it in half, it'd be a smaller chunk, and you cut it in half. Theoretically, if you cut it in half enough times, you'd eventually get down to 1 individual atom of gold, and it would have all the chemical properties of gold. Okay? So that 1 atom of gold, or the 1 atom of whatever other element we might be talking of, has this basic arrangement. In the very center of the atom is the nucleus, and found in the nucleus would be protons and neutrons, color-coded here green and brown, or purple. So a proton, notice there's a plus sign. Protons have a positive charge with them, and the neutrons are chemically neutral, which is why they're called neutrons. And they're going to be found in the center nucleus of an atom. And then surrounding it, and actually a great distance away from the nucleus, way out in space, I mean, we're talking super, super microscopically small, but surrounding the nucleus in what's sometimes called an electron cloud or electron shells, are found the electrons, color-coded yellow here. And notice they have a negative charge, right? So the electrons are charged and the protons are charged. Notice that the charges are opposite of each other. Protons are positively charged, electrons are negatively charged. That's one of the forces that keeps an atom structurally solid and combined, and prevents these things from just flying off into space, right? The negative charge of the electron is attracted to the positive charge of the proton. Kind of keeps everything together. Okay? So the nucleus, protons and neutrons out in the periphery, electrons in the electron cloud. Okay? These things, protons, electrons, and neutrons, are called subatomic particles because they're smaller than the atom itself. The atom is made up of these subatomic particles: protons, electrons, and neutrons. All right? When the proton numbers equal the number of electrons in an atom, the entire atom has a zero net charge and is considered neutral. Like this example of this particular atom with 2 protons and 2 electrons. This happens to be something called helium, because helium has 2 protons. And when helium has also 2 electrons, which it usually has, it is a neutral element or a neutral atom. And because of that, it tends to not be reactive, or it tends not to form chemical bonds. Okay? But anyway, if the number of electrons is equal to the number of protons, that particular atom is neutral. Okay. Now, in the nucleus, as I mentioned, are found the positively charged protons and the neutrons, which are neutral. And then the electrons move around the nucleus in what's called the electron cloud. Sometimes it's called an electron shell or electron shells. Okay. So all atoms of a particular element have the same number of protons. That's consistent. That's so consistent that the number of protons is what is used to identify an element, and it's called the element's atomic number. Okay. So this particular element with 2 protons I mentioned is helium. No other element has 2 protons in its nucleus. If it did have a different number, if an atom had 3 protons in its nucleus, it's not helium, it's something else. It's something different. So the number of protons in the nucleus, the atomic number, is used to identify elements. Okay? It's like if I told you, hey, I saw a vehicle in the parking lot with 2 wheels that somebody was pedaling. You would call it a bicycle because it has 2 wheels. And if I said, hey, I saw something with 3 wheels in the parking lot, you would call it a tricycle because it had 3 wheels. And then if I said, hey, I saw someone riding a 1-wheeled vehicle, you would call it a unicycle because it had 1 wheel. So for those vehicles, what identifies them is the number of wheels. For an element, what identifies it, where's my cursor? Here we go. What identifies an element is the number of protons in the nucleus. Okay, so helium, for example, He is its abbreviation, has 2 protons in the nucleus, so its atomic number is atomic number 2. Okay, let's get into chemical bonding and molecules. Like how the atoms come together to form a chemical bond and how that forms molecules or compounds. Okay? So, only the electrons are involved in chemical reactions. And that's because buried deep in the center, in the nucleus, if you remember what's found there, protons and neutrons. The electrons are found out, outside in the electron clouds, or electron shells. So if 2 elements come together and form a chemical bond, it's because the electrons interact. Okay?